You and I are standing at the edge of the greatest leap in human history. We are going back to the moon, and this time we are staying for good. That is the actual promise drawn up by the American government, the National Aeronautics and Space Administration, and dozens of international and commercial partners. If they can truly stick to this massive blueprint, what we are witnessing right now is so much more than just planting boots and flags in the lunar dust. We are watching the exact moment our species figures out how to survive in the terrifying, beautiful void of space. The rockets are already being prepped, and the reality of leaving our home world is finally sinking in. Touching down safely is definitely not easy. But honestly, it is not the hardest part of the mission anymore. We have pulled off lunar landings before, but as we watch these new plans unfold, what comes next is something entirely uncharted. We actually have to build out there. We are looking at constructing a permanent lunar settlement from scratch. We are essentially trying to raise a small city on a completely alien, hostile world. And the terrifying truth is that no one is exactly sure how this is going to play out. We are stepping into the dark, armed only with our technology and our desperate hope to become an interplanetary species. Every single step forward is a wild experiment in human survival. The good news is that we are not going in blind. We actually have some incredibly practical and strange new solutions for sustaining life beyond Earth. First off, we have to talk about where this lunar outpost is even going to be built. The moon is a massive, desolate place, and every single time humans have landed there before, they stuck right near the equator. They chose nice, flat, relatively safe plains that made direct radio communication with mission control incredibly simple. But watching this new era dawn, you realize those easy days are over. We are pushing into places that are much darker, much colder, and far more demanding than those early equatorial landing sites. But those safe, flat landings were back in the 1960s. This time around, as we watch humanity prepare for our grand return to the lunar surface, the target is infinitely more fascinating and deeply treacherous. We are aiming straight for the lunar South Pole. Looking closely at the orbital maps of this region, you can see it is absolutely littered with massive impact craters, towering mountain ranges, and the jagged scars of ancient volcanoes. It is a rugged, unforgiving landscape that looks like it wants to break any machine or human that dares to touch down. Yet this exact danger zone is where our future begins, holding secrets we desperately need. Down in some of those deep, low valleys and ancient crater beds, the ground exists in permanent shadow. It is chilling to think about, but the dirt down there has not felt the warmth of sunlight in millions, maybe even billions of years. Because of that brutal, endless freeze, scientists are almost certain it is packed with raw water ice. That is ancient water carried into our inner solar system by violent asteroid and comet impacts long ago. Watching the preparations for the Artemis program, you can see the space agency has already circled 13 potential landing sites in this pitch-black, icy wasteland. This frozen water is the exact resource that could keep our future astronauts alive. Those 13 chosen targets are mostly just tiny, narrow patches of sunlight, clinging to the edges of crater rims or the peaks of low mountains. They are completely surrounded by swallowing shadows and the most punishing, rough terrain imaginable. As you and I witness this mission take shape, it is clear this will be a deeply fascinating frontier for raw scientific discovery. But make no mistake, it is going to be equally terrifying and dangerous for the brave crews who will actually have to live and work out there for weeks or even months at a time. One wrong step into the darkness, one failure of their fragile life support systems, and the cold void will simply claim them. Surviving that extreme landscape is going to require space infrastructure unlike anything humanity has ever built. Every single fundamental thing we take for granted in a city on Earth has to be completely recreated out there, in the most hostile environment imaginable, using incredibly limited resources. So where do we even begin watching this construction process? Surprisingly, it starts with roads, despite the old movie quotes. Where we are going, we absolutely do need roads. We need paved paths, reinforced landing pads, and solid surfaces just to keep our heavy equipment from sinking or failing as we try to build out our very first permanent lunar settlement, the massive hidden danger that engineers have to solve right now is simply the dust. The entire lunar surface is coated in this relatively thin, yet incredibly light and fluffy layer of ultra-fine powder. But do not let the word fluffy fool you when you look at this stuff. Under a microscope, you realize each individual grain of this moon sand is jagged, sharp, and highly abrasive, exactly like tiny shards of broken glass, because there is no wind or water to smooth the edges over time. This static, charged dirt clings to everything it touches. It is a silent, microscopic threat that can quietly destroy millions of dollars of hardware before we even realize what is happening. We actually saw the true damage of this material during the original Apollo missions. This razor-sharp dirt was known to literally slice right through the tough outer layers of thick spacesuits. It severely scratched the protective glass on the helmets, blinding the crew over time. To make matters even worse, the dust is highly electrostatic and clingy. It sticks to absolutely everything. We watched as dust accumulation on the lunar roving vehicle caused the machine to critically overheat simply by clogging up its delicate radiator fins. If we are going to establish a real foothold out there in the dark, we have to figure out how to beat this creeping, abrasive menace. The truly terrifying trick about this environment is that without a thick atmosphere to slow things down, and with barely a fraction of our normal gravity, kicked up dust can really travel far. When Apollo 12 landed, they purposefully tried to set down as close as possible to an old robotic probe called Surveyor 3. That probe had already touched down on the gray dirt a few years earlier, and the space agency wanted their crew to go take a look and check in on its condition. But what they found when they walked over there gave engineers back home a massive wake-up call about the physics of rockets firing near fine dirt in a pure, silent vacuum. When those astronauts finally walked over to the old probe, they saw that even though their spacecraft had landed over 180 meters away, Surveyor had been completely sandblasted. The violent exhaust from the lander rocket engines had fired a spray of jagged dust across the plane like a shotgun blast. So looking at the plans for our future, if we are going to build a sprawling moon base where heavy cargo ships are constantly landing, lifting off, and huge rovers are driving around, we have to completely eliminate this flying debris. Otherwise, our brand new outpost will literally tear itself apart from the outside in with every single launch. To survive that constant sandblasting, we absolutely must lay down hardened roads, reinforced landing pads, and smooth surface areas all around the primary base camp. The quick and somewhat dirty answer in the short term could actually be something called rhino snot, that is, the highly descriptive nickname the United States military gave to a specialized chemical spray product. They use this sticky liquid out in the field to instantly stabilize loose dirt roads and temporary helicopter landing pads. It is strange to think that our first real defense against the brutal environment of deep space might just be a military-grade glue sprayed out of a pressurized hose. This chemical spray was incredibly popular during operations in Afghanistan, specifically for turning loose, blowing desert sand into a hard, solid crust. Combat engineers found it particularly useful for completely eliminating the blinding dust clouds that were constantly created by heavy helicopter takeoffs and landings. So as we watch these space agency engineers sketch out their blueprints, that sticky spray is a very real, very practical potential solution for the short term. It could let the first few cargo ships touch down without blasting the early habitats to shreds. It is a crude fix, but when you are 50 million miles from a hardware store, you use what works. But let us be honest, spraying glue everywhere is definitely not ideal. We would have to transport hundreds of heavy barrels of this material all the way from Earth at an astronomical cost. Plus, we would basically be polluting a pristine world right out of the gate, filling the gray dirt with toxic microplastics. So if we want a truly sustainable answer, something that can actually be scaled up to support a growing lunar city, we have to look at the dirt itself. The brilliant, almost science fiction idea they are developing right now is to simply melt the alien surface into thick, solid slabs of black glass. It sounds crazy, but it might be our only real way forward. This melting concept is actually something the European Space Agency is actively working on right now, running a fascinating project they call the Paving the Road experiment. Inside their labs, engineers have been taking piles of highly accurate, simulated moon dust and blasting it with a terribly powerful laser. They are trying to melt that abrasive dirt directly into a smooth, solid, glass-like surface. It is wild to realize this exact idea kind of dates all the way back to 1933. Back then, visionaries genuinely thought you could pave massive highways through the deserts of Earth just by dragging giant heaters to melt the sand into glass. It actually makes perfect sense when you think about the basic chemistry. Glass is literally just melted sand that has been cooled quickly. Now, dragging giant ovens across the Sahara was wildly impractical for that time and place on Earth. But watching the blueprints for a future moon base come together, you start to realize this thermal melting trick might literally be the absolute best option we have got. The beauty of this plan is that we probably will not even have to pack a massive, heavy industrial laser into a rocket to make it work. Out there in the harsh vacuum, we have access to an unbelievable amount of raw, unfiltered energy raining down from the sky every single day. Instead of heavy lasers, what the crews could actually do is deploy a massive magnifying glass to capture and concentrate the raw, unfiltered sunlight. Specifically, engineers are looking at using something called a Fresnel lens. If you have ever seen a lighthouse up close, it is the same concept. It concentrates intensely bright light by using carefully angled grooves carved directly into a flat, lightweight piece of clear plastic. By using this clever design, the space agency completely eliminates the need to launch a giant, heavy, and easily breakable curved piece of glass into orbit. It is an incredibly elegant way to harness the lethal power of the sun for our own survival. The math shows that this specialized Fresnel lens would only need to be just under 2.5 meters wide to generate the insane temperatures required to melt rock. But there is a catch. When you look at the jagged geography at the lunar South Pole, the sun hangs incredibly low on the black horizon, casting massive, miles-long shadows across the ice. Because of that terrible lighting, the crews might actually be forced to bring heavy backup lasers as well. Either way they tackle it. Paving roads on a dead world is going to be a grueling, agonizingly slow process. Every single square foot of melted glass will be a hard-fought victory against the freezing vacuum. The brilliant European teams running these melting experiments currently estimate that our machines could forge a 100-square-meter landing pad with a solid thickness of just 2 centimeters in about 115 days. When you crunch the numbers, that is something like 100 times slower than a construction crew paving a normal road with traditional asphalt back home. So it is going to be a monumental, tedious job that takes incredible patience, but we have to get those solid paths built because humanity is about to spend a massive amount of time driving heavy rovers across the dark, freezing plains of our nearest celestial neighbor. Once those glass roads are glowing and cooling, our primary transportation will be heavy, fully pressurized rover vehicles. You can actually see the prototypes right now, like the incredible machine being developed by the Japanese space program in a historic partnership with Toyota, officially called the Lunar Cruiser, massive armored rovers. Exactly like this will be how our crews safely move around the expanding moon base. The genius of the design is that astronauts will completely avoid the exhausting danger of getting in and out of bulky space suits all day. You will simply float directly through a sealed tunnel from your warm habitat right into the cockpit of your waiting truck. These heavy pressurized vehicles are also exactly how we will dare to explore deep into the uncharted wild. The Lunar Cruiser is essentially an armored recreational vehicle built for the harshest terrain in the solar system. The specs are incredible. It can safely support 2 astronauts on a tense, remote road trip that can last for 30 days or more. It is entirely powered by a highly efficient, silent hydrogen fuel cell. Now you and I both know having a high-tech space truck to drive across the craters is amazing, but you cannot live in a truck forever. When the long patrol is over and the dust settles, where do our pioneers actually go to sleep without freezing to death? To really understand how we survive up there, we need to break the housing plan down into short-term emergency accommodation and long-term permanent bases. Building a sprawling lunar city is absolutely not going to happen overnight. It will take decades of dangerous, backbreaking labor, but the space agency has already fully designed our very first official lunar house. And the blueprints are stunning to look at. They officially call this metal sanctuary the foundation surface habitat. It is the crucial beachhead. Watching this metallic shelter roll off the assembly line, you realize this is the actual fragile bubble that will keep our first permanent settlers breathing. This incredible habitat is a towering 3-story structure that seamlessly combines a rigid, heavy metal frame with a flexible, bulletproof inflatable module. The entire system is engineered to keep up to 4 crew members alive and sane over a tense time period of about 1 month. In reality, though, the foundation module will mostly be occupied by just 2 solitary astronauts, while their 2 partners are out navigating the pitch-black craters in that heavy pressurized rover. The base ground level of this structure is a solid, heavily armored metal cylinder that measures exactly 4 meters across. It is a tiny, cramped fortress standing alone against the endless cosmic radiation. Down in that cramped metal ground floor, the crew will maintain the critical airlock systems and store their bulky, dust-covered spacewalk suits. It also holds a tightly packed science station entirely dedicated to running rapid geological experiments on freshly mined lunar dirt when their shift is done. The exhausted astronauts will climb a central ladder up into the flexible second level of the inflatable module. Up here, the stark white walls stretch out to a much more comfortable 6.5 meters across. This middle deck is the crucial survival zone where they keep the complex water recycling hygiene units and the heavy exercise gear they desperately need to fight off muscle loss. Tucked alongside the exercise gear, there is also a miniature sealed biology lab. Here, scientists will intensely study the harsh effects of partial gravity and solar radiation on delicate green plants and small organisms. It is all about figuring out how to grow our own food out in the dark. Then, finally climbing up into the third level, you find the primary, quiet living space for the crew. This is the heart of the home. Up here in the dome, they have small sleep pods, a highly advanced emergency medical station, a compact rehydrating kitchen, and their main communication workstations. It is a tiny, glowing pocket of human warmth surrounded by absolute, freezing nothingness. Right next to their bunks, there is also a specialized human research lab, out here on the ragged edge of survival. The astronauts themselves willingly become the medical guinea pigs. Every drop of blood and hour of sleep is tracked in a relentless study to see exactly how long-term lunar habitation slowly breaks down the human body. Now, if we can successfully survive this terrifying foundation period without losing a crew, the real work begins. We will desperately need to start constructing massive, permanent structures out of the alien dirt itself. We need heavily armored bunkers that can actually guarantee real protection and long-term psychological security for a growing population. The threats out there are invisible and relentless. We absolutely must find a way to insulate our fragile bodies from the constant, lethal bombardment of invisible cosmic radiation. We have to violently mitigate the effects of those wild, hundreds of degrees temperature swings that happen between the blistering lunar day and the freezing black night. On top of all that, the colony needs heavy physical shielding to survive the terrifying, random strikes of micrometeorites falling from the sky. To accomplish this massive feat of planetary survival, engineers are looking backward. We are returning to the absolute beginning of ancient human architecture. We are going to build with bricks in the exact same brilliant way that lab engineers believe we can blast the dirt with lasers to pave thick glass roadways. They are also convinced we can literally bake that toxic moon powder into heavy structural blocks. The underlying survival strategy here is fascinating. We would still land and inflate those lightweight pressurized habitats or rigid metal cylinders for our airtight living space. But as soon as they are up, heavy autonomous rovers would immediately begin burying them, entirely encasing the delicate human bubbles inside a massive, interlocking shell of dark baked brickwork. It is the ultimate cosmic fortress built from the very dirt trying to kill us. Burying the habitats under those heavy baked blocks should instantly mitigate almost all of the lethal dangers from deep space radiation and those hypervolcanic micrometeorite strikes. Plus, that thick shell of dirt provides a massive insulating thermal layer, making the delicate heating and cooling systems inside the colony far more stable and energy efficient. Watching the global space race heat up, it is amazing to see that China has actually already begun actively testing their own version of these heavy moon bricks. Their space administration's wild idea is to use autonomous robots to assemble a massive, egg-shaped bunker complex they officially call the Moonpot vessel, Stick with me here because the engineering behind this is mind-blowing. The entire construction of this massive base would be handled completely by robotic rovers before humans even arrive. They plan to weave together ancient, traditional Chinese masonry techniques with heavily compressed bricks made completely out of local lunar soil, all supported by massive three-dimensional printing rigs. In 2024, their scientists fired up a huge experiment to press blocks out of 5 entirely different simulated lunar dirt recipes. They rigorously tested 3 distinct, high-energy methods for rapidly baking that loose, abrasive dust into incredibly dense, solid rock blocks. Following those intense thermal tests, later that November, they actually loaded up those heavy prototype blocks into a cargo ship and fired them directly up to the Tiangong space station in orbit. Once docked, astronauts carefully moved those dark bricks out onto an external, unshielded experiment rack bolted to the hull. Now, those chunks of compressed dirt will spend the next 3 excruciating years being violently exposed to the pure vacuum of space, relentless cosmic rays, and brutal thermal shock. Scientists back on Earth will be watching the telemetry closely, waiting to see if these blocks crumble into dust or if they truly hold the key to our survival out in the dark. But if you want to see something truly out of a science fiction movie, there is also this incredibly wild architectural concept floating around. American engineers want to combine that intense thermal glass melting process with robotic habitat construction to print a massive, glowing, solid glass sphere directly into the lunar crust. At first glance, the renderings of this giant transparent bubble look absolutely insane and utterly impossible, but a private aerospace company called Skyports has officially secured serious grant funding directly from the NASA Institute for Advanced Concepts to make it real. It is terrifying and beautiful, and it proves we are really doing this. I want you to picture what it looks like as we stand on this silent, gray frontier, watching humanity build its first real walls off the Earth. The machines out there are doing something that looks like industrial glass blowing, but on a massive scale. They scoop up the raw, jagged moon dust and superheat it until it melts into a glowing, molten goo. Then, using blasts of compressed gas, they inflate that glowing sludge into an enormous dome, out here with absolutely no atmosphere pushing back and barely any gravity pulling down. You do not even need to blow that hard. The structures just keep swelling outward, growing to humongous sizes without collapsing on themselves. It is beautiful but completely terrifying to realize this thin shell is all that keeps the vacuum out. As we watch these glowing bubbles cool into dark shells against the blackness of space, the process repeats to give colonists extra insulation and protection from radiation. Machines blow multiple layers of lunar glass, leaving thick air gaps between each one. It operates exactly like a heavy-duty, multi-pane window back on Earth. It might seem a little crazy, and maybe it is not the most practical first idea anyone ever had, but looking at it, the whole thing is undeniably brilliant. There is just one massive catch to all of this construction. None of these giant machines or the life support systems inside those domes will work without an incredible amount of power. So, where exactly do we get that juice? The obvious answer is hanging right above us in that pitch-black sky, the sun. We all know the sun. And most lunar missions throughout history have relied almost entirely on solar panels. For a long time, catching rays worked well enough to keep our little machines running. But as humanity tries to put down permanent roots in this hostile dirt, we hit a massive wall with solar energy. The moon rotates on its axis incredibly slowly compared to the Earth. Because of that sluggish spin, anyone standing on the surface has to endure a deeply punishing cycle of day and night. It completely changes the rules of survival when you cannot count on a sunrise every 24 hours to recharge your dying batteries. Out here you get roughly 2 continuous weeks of blinding, radiation-soaked sunlight, followed immediately by 2 endless weeks of absolute freezing darkness. That extreme schedule was never really a problem for the Apollo crews because those guys were only ever walking around up here for 3 to 4 days at the absolute maximum. But the moment we try to leave an autonomous lander or a solar-powered rover behind, the clock starts ticking. They can drive around and do their jobs beautifully for 14 days, but the second that long night falls, the temperature drops so fast and so hard that the machines freeze totally solid for the next 2 weeks. It is a harsh reality of surviving in a vacuum. But most of those frozen robots just never wake back up once the sunlight finally creeps over the horizon. The cold snaps their circuits, and even if they do manage to power on, they just never run the way they used to before. The long night set in. Now you and I need to look closely at the map of the 13 potential Artemis landing zones. When you scan those orbital photos, you will notice massive pools of deep, dark shadows inside the craters. Because of the angle of the sun at the lunar South Pole, most of those jagged trenches are stuck in permanent freezing shade. They have not seen a single drop of warmth or light in billions of years. Sunlight physically never reaches the bottom of those deep craters. And ironically, those pitch-black freezing depths are the exact locations where humanity is absolutely guaranteed to find the raw water ice we desperately need to keep our lunar city breathing and drinking. We cannot build solar panels in the dark, so if we want to survive down in the shadows, the only real answer is to go nuclear. Generating nuclear power in the blackness of space is not a brand new concept for us. China has actually been driving a nuclear-powered rover around the far side of the moon for a few years now, creeping through the gray dust on a steady, quiet trickle of atomic energy. NASA is no stranger to this either. They have been running massive nuclear-powered rovers across the red dirt of Mars for well over a decade now. Even the legendary Voyager probes, which launched all the way back in the 1970s and are currently sailing through interstellar space, run on nuclear energy. But all of those machines rely on very small-scale, simple setups. Those older generators basically just harvest the passive heat given off by a slowly decaying chunk of naturally radioactive material. Then, through a direct thermal conversion process, they turn that warm glow into a tiny trickle of electricity, usually just a few watts. Just barely enough to keep the lights on. A handful of watts is perfectly fine if you are just keeping a lonely robot alive in the freezing dark, but you absolutely cannot scale that passive decay up to something that would run the life support systems of an entire sprawling lunar base. For that, humanity needs to build an actual functioning nuclear power plant right here on the surface of the moon. And standing here, watching the cargo landers come down, that is exactly what NASA has spent several years designing. They call this ambitious leap the Fission Surface Power Project. And it changes everything about how we operate off the Earth. We are moving from simple batteries to splitting the atom in an alien wasteland. This new machinery uses the exact same violent fission reaction that forms the beating heart of every standard nuclear power plant. Back home on Earth, deep inside the reactor core, you split heavy atoms of uranium fuel, which instantly releases a totally tremendous amount of energy that manifests purely as blistering heat. But out here in the vacuum of space, we have absolutely zero lakes or rivers to boil into steam to spin a massive turbine. Instead, engineers had to get creative. We take that intense atomic heat and run it through specialized piece of hardware called a Brayton converter. That closed-loop system is what actually turns the raw, searing temperature of split atoms directly into usable electricity. The internal engineering is incredibly complicated. But honestly, you and I do not need to worry too much about the deep physics of how it operates. The important thing is that it just reliably works. And strangely enough, one of the biggest advantages to building our city near those terrifying, shadowy craters that never see the sun is thermal management. We can take this red-hot nuclear reactor, lower it straight down into the permanent freezing darkness of the crater floor, and it will basically never overheat. The cold void actually works with us, not against us. The only real trick left for the engineers back home is figuring out how to keep these complex atomic engines small enough to launch. NASA set down some brutally strict specifications for this hardware. The total weight of the reactor needs to stay completely under 6 metric tons, and the entire outer housing cannot be any larger than your average 4-door family car. Now, in the world of heavy nuclear power plants, cramming a fission core into something that tiny is incredibly difficult. But in the fragile, Waitob's-essed world of orbital space launches, a 6-ton piece of cargo is still a massive beast to push through the atmosphere. To pull this off, aerospace agencies looked for outside help. Right now, Rolls-Royce is actually one of the private companies heavily leading the way in developing this space-based nuclear technology. When you hear that name, most people immediately picture super luxury cars gliding down city streets, complete with leather seats and a little hood ornament. But there is a totally different, highly classified side to that company. Rolls-Royce has actually been designing and manufacturing ultra-compact, highly reliable nuclear reactors for the British Navy submarines for well over 60 years now. They know exactly how to build a nuclear engine that can operate flawlessly in an incredibly hostile, high-pressure, totally isolated environment where failure means certain death. So they already have a massive amount of life-for-death experience in this highly specialized field, sitting right there in the lunar dust. Their current micro-reactor design is steadily aiming to pump out between 50 and 100 kilowatts of constant electricity. Just to give you a sense of scale, hitting the high end of that target would be more than enough to power a small industrial factory or several average-sized houses back on Earth. So, landing just one of these compact mechanical hearts would be plenty of juice to get our very first small moon base running smoothly. Once we prove the concept works, we would simply need to fly up a few more, stack them together on the crater floor, wire them into the grid, and suddenly we have enough raw energy to power a sprawling, fully illuminated moon city. So there it is, standing against the absolute silence of the void, our very first permanent outpost beyond the protective cradle of the Earth, acting as a glowing gateway to the rest of the solar system. If we can figure out how to not just barely survive the freezing dust of the moon, but actually thrive, build, and expand our footprint, then we have officially unlocked new possibilities in space that would never be possible if we just stayed home. Stick with me as we watch this happen, because this is the exact moment humanity learns to truly live among the stars. This is how we push past our fears, master the terrifying beauty of the universe, and boldly Go where absolutely no one has gone before.